is equal to x to the fourth plus 12x squared Okay, welcome back. This is 3.8 notes, part 3. See how I've got 3 more problems left. We're going to see how long it takes me to do them. It might take me a while, but all we're trying to do is to calculate the derivative of each of these equations, to find dy dx. So what I'm going to do is I'm going to first take the derivative with respect to x of each of these terms, okay? Okay, so of x cubed, right, plus ddx of y cubed is equal to ddx of 18 times x times y. Okay, so if I take my derivative with respect to x, I want to look to make sure if the x's match. Okay, if the x's match, I'm going to take my normal derivative. Okay, and we're just going to get 3x squared. Okay, but if I look here, I'm taking the derivative with respect to x, and I have a term that has a y in it, I have to use the chain rule. Okay, and I have to take my normal derivative, so I get 3y squared, and then I multiply by the derivative of y with respect to x, so dy dx. Okay. Now, over here we've got a different thing going on. Okay. So what I want you to notice here is that I have 2 functions. Okay. I have 18x. And then I have a y, and I'm multiplying in between those, okay? I'm going to call this my u, and I'm going to call this my v, all right? So u is equal to 18x. Okay, not negative x. Let me erase that. Okay, 18x. All right, and my v is equal to just y. All right, so if u prime then is going to be just 18, and then v prime is going to be dy dx. Okay, so to do the product rule, I want to cross multiply and add them together. So I'm going to take u times v prime, so that's going to give me 18 x times dy dx, okay, and then plus 18 times y, so plus 18y. Okay, so now we have an issue. Okay, we've taken the derivative, but we need to solve for dy dx, okay? And so I'm going to solve for that now. And the trick is to get your terms with dy dx on one side of the equal sign. Okay, and it doesn't matter which way you go, but I'm just going to go ahead and subtract 18x times dy dx. Okay, I'm going to do that to both sides. So minus 18x times dy dx. Okay. Now, the other thing I want to do is I want to get all of the other terms that do not contain dy dx, mainly 3x squared and 18y. I need to get those on the other side of the equal sign. So I'm going to subtract by 3x squared from both sides. So minus 3x squared. And it should be a 2. Okay, and as a result, this is what we get, okay? We're going to get 3y squared times dy dx, okay, minus 18x times dy dx. okay, and that is equal to, I'm going to do 18y minus 3x squared, okay? Now, the trick is, on these problems, is that you want to factor out a dy dx here, okay? You have a dy dx in each of those terms. You can factor out, and you can factor it out because you're multiplying, okay? So I'm going to take hold on, all right, dy dx. I'm going to factor that out. And I'm left with 3y squared minus 18x, okay? And I'm going to set that equal to 18y minus 3x squared, okay? And then I'm going to divide everything on this on both sides by 3y squared minus 18x. Divide over here by 3y squared minus 18. Okay. 18x. Sorry, that should just, there we go. Okay. So this divides out over here and here, but I can then write my derivative as, I'm going to do whoops. Okay, I'm going to do dy dx is equal to 18y minus 3x squared all over 3y squared minus 18x. Now, if you had moved things on the other side of the equal sign, some of these things will kind of be backwards and stuff. But by factoring out some negatives and doing a few things, you know, we can get them to look like the same thing. So this is the derivative, okay, of that equation, okay? And so notice that you have y values in your derivative and you have x values in your derivative. So these are equations. These aren't functions. These are like circles and ellipsoids and all sorts of stuff that are not functions. They are equations. So, okay, now let's go ahead and move on. I'm going to do number 10 over here, okay? Now, the first thing I notice about number 10, guys, is that I have the product of two functions, okay? I've got xy and I've got xy, okay? And we're multiplying those, okay? So, what I want to do is, let's do that up here real quick. I'm going to rewrite this first as x times y is equal to cotangent of x times y, okay? And what I'm going to do, guys, is I'm going to take the derivative of each of these terms, okay? I'm going to take the derivative with respect to x, okay? The derivative with respect to x, okay? Now, when I do that, I notice here that I have the product of two functions, okay? I have the function x, okay? And then I'm going to call that u, and then up here I have the function y. I'm going to call that v. So u is equal to x, and v is equal to y. Okay, and if I find the derivatives of those with respect to x, over here, u prime is equal to 1. Over here, v is equal to dy dx. Okay, so I cross multiply and add if I'm doing the product rule, and so I get x times dy dx plus 1 times y. Okay, so just y. All right, and this is equal to cotangent of xy. Now, we already have the derivative here of x dy dx. Hold on, let me put an x in there. Okay, so we have x dy dx plus y, and that's a result of doing x times y. So when I'm taking this derivative, I have to do the chain rule twice, okay? And so I'm going to do a little substitution here. I'm going to call this w, okay? And so I'm going to rewrite this here as ddx of cotangent of w, okay? And w over here is equal to x times y. Now, the nice thing is we've already taken that derivative, so we know that w prime is equal to x times dy dx plus y. Okay, this came from over here, all right? So if I take my derivative, I'm going to end up getting, okay, the derivative cotangent is negative cosecant squared of w times w prime. Okay, I'm taking the derivative with respect to x here. This is not x, this is w. So now I can just substitute all that stuff back in. And we do x times dy dx plus y, okay? And then let's substitute everything back in, and so we get x dy dx plus y is equal to negative cosecant squared of x times y. Okay, and then we're going to multiply that by w prime, which is x times dy dx, okay, plus y. And I got to put this in parentheses, all right? Okay, so this is where it gets kind of nuts. All right, so now my objective, guys, now that I've taken the derivative, okay, I need to solve for dy dx, okay? Now this poses a problem over here on the right side. Okay, I have this entire function that I need to distribute here in order to get rid of this multiplication. So what I'm going to do is I'm going to distribute negative cosecant squared of x times y into this part over here on the right. So let me write x times dy dx plus y is equal to, okay, let's see how I want to do this. I'm going to kind of rewrite this a little bit. I'm going to do negative x times cosecant squared of xy times dy dx minus y times cosecant squared of xy. Okay. Now, okay, I'm going to get all my terms that have dy dx in them, so this one and this one on the same side of the equal sign, and then I'm going to get all the terms that don't have dy dx on the other side. So let's go ahead and do that real quick. So I'm going to add x times cosecant squared of xy times dy dx. Okay, I'm going to add that over here, so plus x times cosecant squared of xy dy dx. Okay, I'm going to also subtract y and subtract y. All right, so my next step, sorry, I'm losing space, guys. My apologies. All right, let's do this. Let's write, I'm going to zoom out real quick. Write this up here. All right, so we've got, all right, pardon my usage here. We've got x times dy dx plus x times cosecant squared of xy times dy dx. Okay, and this is equal to negative y minus y times cosecant squared of xy. Okay, so now we want to take out my derivative, okay, of dy dx. We want to factor that out. And so if I write dy dx and if we factor that out, we are left with x plus x times cosecant squared of xy, okay? And over here on the right side, we're still left with negative y minus y times cosecant squared of xy. Okay, so now what I want to do is I want to go ahead and divide, divide both sides by x plus x times cosecant squared of xy on both sides. X plus x times cosecant squared of xy. Okay, so as a result, okay, we're going to get that, let me move down, sorry, we're off the page, that dy dx is equal to negative y minus y times cosecant squared of xy, okay, all divided by x plus x cosecant squared of xy, okay. So this is my derivative. Now we can factor out a y and a y, or a negative y, and an x, and you're actually going to divide some things out. Ultimately, you end up just getting negative y divided by x, okay, as a result. This does simplify. So if you factor that out, you get a 1 plus cosecant squared and then 1 plus cosecant squared. So I hope that this video was helpful. There is a lot going on here. Sorry about the video mishaps. I'm still kind of learning how to use this stuff, so bear with me. So I hope you learned something from this. This was pretty good. So, you know, I'm not going to do the next problem. You can go ahead and do that one. So, I just don't have enough time in this video. So go ahead and start your homework, and hope you enjoyed it. Thanks.